Thank you all for coming. My name is Jacob Nixon. I am taking an Introduction to Speech course with Columbia College Online. This is my second speech. 3 of you were here last week. You two are new, so enjoy the ride. I'm going to start by telling you a little story about a couple identical twins. We'll call them Bill and Leonard. It's the year 2250, and Bill decides he wants to go visit his green-skinned girlfriend in the Orion system 5 light years away. So he hops in a spaceship, gets up to about 90% speed of light, spends 5 years in space. Well, actually, it'd be about 5.5, because not quite the speed of light. He gets there, decides, okay, I made it. Spend a little time with my girlfriend real quick, call home, let my brother Leonard know I made it safely. So he dials him up on his video phone and, is excited to see, the face he sees every day in the mirror, looking back at him. And instead he sees this 80-year-old guy. And it's like, who are you? What have you done to my brother? And Leonard's like, Bill, I am your brother. You didn't take into account time dilation when you went on your journey. Bill, the explorer, doesn't care about science. He's like, what are you talking about? Leonard, being the scientific and logical one, explains to him, the faster you go, the slower time moves for you. Excuse me. Bill's still got a quizzical look on his face, has no clue what's going on. So Leonard's like, well, it's a aspect of Einstein's special theory of relativity. Everybody's familiar with that, E equals mc squared. Basically what it states is that the faster you go to the speed of light, the more energy it requires for mass to move. In effect, slowing you down, your bodily processes, if you will. For instance, and this is going to require a little bit of suspension of common sense and a little bit of imagination because we're not going 90% speed of light. Well, let's say you have a clock. It's 2 mirrors. It's a very simple clock, the most basic clock you can have. You got 2 mirrors, and in between them, you've got a photon, bouncing back and forth. Photons is one packet of light. It hits the first mirror, tick, comes back, talk. That's 1 second. Well, you got an identical mirror next to it. They're synchronized. Well, if you move that second mirror, instead of just going like this, the photon has to travel a greater distance. Now, like I said, that I'm just describing a clock there, but it's actually how all natural processes would work. It's very hard for the human brain to comprehend if you don't have a degree, preferably a PhD in theoretical physics. I know I don't, that's why I'm here today. Now, Bill's starting to grasp it, and Leonard feels a little brave and decides he wants to break out the math. There's a very simple equation to determine how much time, or what the time difference would be. It's delta t divided by the square root of 1 minus velocity squared over the speed of light squared. Yeah, Bill's not a mathematician, neither am I. Neither are anybody here? No? Okay. Speed of light is 186,000 miles per second. That's fast. Very fast. Velocity, to get, it's going to have to be fast because you got to match those numbers if you want to experience these effects. If it's exponential, so take a graph, right here is standing still. As you move across, it slowly increases, and then you hit a critical point where it just shoots up. So the faster you go, the more of the effect you experience, and the greater the effect, the faster you go to. Sorry, I'm quitting smoking, and lungs are clearing up. So anyways, Bill finally starting to grasp this, and he realizes, well, he just kind of gave up his entire life to see his girlfriend. Now, fortunately, this is the year 2014. We don't achieve those speeds. We can't even get close. Speed of light takes 7 minutes to get to the sun from here. Sun to here. It takes us 3 days just to get to the moon. Fraction of the distance. So we don't have to worry about this. The longest anybody's spent in space at a sustained speed is on the ISS. He spent 2 years up there. He came back 22 millionths of a microsecond younger than everybody else. So as you can see, we're not going to experience it. Even if you got, took a baby from the time he was born, put him in an airplane, sent him around the world for his entire life, 80 plus years. He might gain 1 or 2 seconds, but honestly, the wonderful airline food would probably cancel that out. Thank you all for taking the time to do this, and I hope you have a wonderful evening.